Imagine starting a manufacturing business. Right at the exact moment your country's economic bubble just spectacularly explodes.
Oh man, yeah. Well, it's basically the absolute worst possible timing you could ever ask for.
Right. I mean, we are talking about 1991 in Japan. The Nikkei stock index is just in a total free fall. And that whole era of endless corporate cash, where companies are practically just throwing money at experimental projects,
Mhm.
that all just evaporated overnight.
Completely evaporated.
Wow.
And you can imagine the panic setting into the boardrooms of these massive automotive giants. I mean, they are suddenly slashing their budgets down to the absolute bone.
Exactly. It is the literal definition of a chaotic, terrifying time to try and build anything from the ground up.
Oh, absolutely. When a bubble bursts like that, the instinct for almost everyone in the supply chain is sheer self-preservation. You hunker down, you cut corners, and you desperately try to just hold on to whatever tiny, shrinking contracts you have left. Taking a massive visionary risk it was totally counterintuitive to the entire business culture at that moment.
Which is exactly what makes our subject for this deep dive so incredibly fascinating. Because amidst all that financial carnage, you have these two men, Shinsaku Sasaki and Koji Sasaki, who decided to start a company called Sasaki Coating.
And this started with essentially nothing, right?
Pretty much nothing. No massive capital reserves, no guaranteed long-term contracts, just a very modest coating and processing town factory, and this singular, almost stubborn belief of, if you build it, he will come.
And that belief, forged right in the specific crucible of that 1991 crash, is what makes their story so vital for us to look at today. Because what we're looking at here isn't a standard dry corporate history.
No, not at all.
It's really a masterclass in business evolution. We're going to trace how a tiny, vulnerable Japanese subcontractor completely transformed itself into this indispensable global solution provider for some of the biggest automotive giants on the planet. And they didn't achieve this by just like making a slightly stickier tape or a cheaper coating. They completely re-engineered their corporate DNA. They shifted from what the industry calls productization-driven manufacturing over to analysis-led development.
Okay, let's unpack this because we have this amazing stack of internal presentations, strategic reports, and historical data from Sasaki Coding to go through. And our mission for you, the listener in this deep dive, is to figure out exactly how they pulled off this wild evolution.
Right. How do you go from being a tiny factory at the very bottom of the food chain, just taking orders, to becoming the architectural brain behind the manufacturing processes of global giants?
Exactly. And for everyone just listening at home, I have to mention the setup you have going on in the studio today. We are currently surrounded by these massive, incredibly detailed blueprints, cross-sections of automotive interior parts, and literally there are hourglasses sitting on the desk.
Yeah, I brought props.
I love it. It feels like we are sitting inside a laboratory dedicated entirely to time and engineering.
Which is really the perfect environment for this because time and engineering are the two currencies Sasaki Coding learned to manipulate better than anyone else in their field.
Makes sense.
But to understand the nuts and bolts of how they did that, we actually have to start with their operating system, their underlying philosophy, because you simply do not survive the late 90s and early 2000s in the hyper-competitive Japanese auto industry just by working long hours. You need a completely different lens through which to view your business.
And from what I'm seeing in these sources, their way of seeing the world is a very unexpected mashup. Like, I'm looking at references to Peter Drucker, the legendary 20th century management consultant, sitting right alongside references to a 19th century samurai.
I know, it's wild.
How do those two possibly connect?
It's actually a brilliant synthesis. So the samurai you're referring to is Sakamoto Ryoma. During the really chaotic, violent end of the samurai era in the 1860s, Ryoma famously wrote the Senshu Hasaku.
Okay, and what was that?
It was basically an 8-point master plan to completely redesign the Japanese nation for a modern era. So Sasaki Coding looked at their own chaotic era in the 90s and adopted that framework, creating the Kichu Hasaku, their own 8 guiding strategies to redesign their business.
Oh, wow.
Yeah, and they fused that samurai structural ambition with a core tenet from Peter Drucker, which is the idea that the ultimate goal of marketing is to make selling unnecessary.
Okay, I have to pause you right there because making selling unnecessary sounds like a totally utopian business cliche.
Oh, it definitely sounds like one on the surface.
Right. It's like a chef saying, my food is so incredibly good, I don't need a menu, I don't need waiters, and I don't need a sign on the door. People will just instinctively wander into my kitchen and hand me cash.
Mmm.
I mean, how does a small parts supplier actually execute that in the cutthroat automotive industry?
It's a fair question.
You can't just run a decent factory and assume these massive corporations are going to blindly throw contracts at you without a pitch.
You're entirely right to be skeptical. And, well, if they were just focused on making a good physical product, it would absolutely be a cliche. But Sasaki realized that to make selling truly unnecessary, you have to fundamentally change what it is you are selling. You aren't selling a physical roll of adhesive tape anymore. You are selling the elimination of risk.
The elimination of risk. Okay.
Yeah. To understand this, you have to look at the automotive food chain. You have the automakers at the top, and below them are the Tier 1 suppliers.
Right. Let's define that for a second for the listener.
Hmm.
Tier 1 companies are the massive multi-billion-dollar corporations that supply entire, fully assembled systems directly to the automakers.
Exactly.
So they aren't just selling a piece of plastic. They're selling the entire dashboard assembly or the entire seating system. And Sasaki, as a Tier 2 supplier, is trying to sell their specific coatings and tapes to those Tier 1 giants.
Precisely. And in the late 90s and early 2000s, those Tier 1 giants companies like Toyota Gosei and Denso were facing incredibly strict new demands from the automakers. For example, Toyota Gosei was tasked with creating these massive 1,500 millimeter wide materials that were breathable but also low VOC.
Meaning low volatile organic compounds, basically the chemicals that give you that famous new car smell, but which are actually terrible for human health and the environment.
Yeah.
Automakers suddenly wanted those chemicals gone.
Right. But here is the engineering nightmare. Those very chemicals are often what make the adhesives actually stick and perform well under extreme temperature changes inside a car.
Oh, I see. So the automakers are demanding that the Tier 1 suppliers remove the chemicals, maintain the exact same performance, and, let me guess, do it without raising the price.
You guessed it. And when faced with those punishing demands, most Tier 2 suppliers basically ran for the hills. The margins were just too tight, and the risk of failure was way too high.
Yeah, I probably run too.
Right. But Sasaki did the exact opposite. They looked at those hard problems and realized that extreme difficulty wasn't a barrier. It was the ultimate competitive moat.
Because if you can solve the headache that makes your competitor quit, you don't even have to fight for market share. You just own it.
Exactly. If you can anticipate a customer's manufacturing nightmare like a flaw that will cost them millions down the line, and you eliminate that risk before production even begins, you don't need to sell them your product. They have no choice but to hire you because you are the only one holding the cure to a disease they didn't even fully understand yet.
Okay, that makes sense conceptually, but it brings up the massive question of how. How does a Tier 2 supplier anticipate a disease inside a giant Tier 1 company? Because these are massive labyrinthine corporations.
Right. To do that, Sasaki developed a methodology they called TES, or Total Engineering Service. And to understand why TES was so revolutionary, we have to talk about the fatal structural flaw of giant manufacturing companies. And that flaw is siloing.
Siloing. The classic corporate right hand not talking to the left hand.
Exactly. When a company gets massive, its departments naturally isolate from one another. You have the design department, whose only job is to make a part look beautiful and ergonomic. So they draw this incredibly sleek, complex, curved interior panel and basically toss the blueprint over the wall saying, "Make this."
And then the production department catches it, looks at the math, and says, this is physically impossible to build at scale on an assembly line.
Spot on. And meanwhile, the purchasing department is sitting in a completely different building, and their only mandate is, whatever you guys figure out, the materials have to cost 3 cents less than they did last year.
Sounds like a nightmare.
It is. It creates what engineers call a loss of overall optimization. Everyone is optimizing for their own specific, narrow metric, and the final manufactured product suffers. The whole process just becomes a mess of compromises, friction, and hidden costs. Sasaki's TES methodology was designed to step directly into that gap.
So they realized their job wasn't just to quote a price for tape to the purchasing department.
Right. Their job was to act as the translator and the orchestrator between all these divided, warring factions.
Here's where it gets really interesting for me. Do the sources give a specific example of them catching one of these massive mistakes before it happened?
They do, and it's a perfect illustration of how this works. There's a case study in the internal documents referred to as the 400D project. This was for a complex armrest component. Usually, a Tier 2 supplier gets a request for materials, they quote a price, and they sit back and wait.
But Sasaki didn't do that.
No, Sasaki didn't do that. When they got the request, they took the customer's 3D CAD data, the raw digital design files, And within exactly 6 days, they ran full digital simulations and 3D printed physical prototypes.
Hey, 6 days. That is lightning fast in this industry.
It really is.
And what did they find in those 6 days?
They found the hidden disease, they analyzed the geometry of the armrest, and they discovered that at a very specific, sharp curve, a 24 millimeter radius, which they dubbed R24, the material would inevitably wrinkle during mass production.
Oh, wow.
And it wasn't a maybe. Based on the physics of the material tension, it was a mathematical certainty.
Let's break down the mechanics of that for a second. Why does a 24 millimeter radius cause a wrinkle? Think of it like trying to wrap a flat piece of paper tightly around a baseball. The center might lay flat, but as you pull the edges around the curve, the excess material has nowhere to go. It bunches up, it creases.
That's a great way to visualize it.
So, if Sasaki had just supplied the adhesive tape like a normal vendor, the customer would have spent a fortune casting the heavy metal mold, fired at the assembly line, and suddenly realized that every single armrest coming off the line had an ugly, unacceptable wrinkle in the fabric.
It would have been a catastrophic, multi-million-dollar mistake.
But Sasaki didn't just walk into the design department, point out the flaw, and say, well, good luck fixing that. They provided the cure, right?
Exactly. Before the customer even cast a single mold, Sasaki went back to them and said, at R24, your design will fail. But if we engineer custom slit shapes into our adhesive tape, it will completely solve the problem.
So back to the paper and baseball analogy. If you make strategic, highly precise cuts in that piece of paper, it can suddenly expand, flex, and hug the curve of the baseball perfectly without bunching.
Yes, exactly. And they took it one step further. They didn't just engineer the tape, they custom-built an application jig for the customer's assembly line.
A jig being essentially a physical template or a guide.
Right. By using this custom jig, Sasaki ensured that any worker on the assembly line could apply the material perfectly every single time without needing the sixth sense or touch of a master craftsman.
It's brilliant. I used an analogy earlier about a couples therapist, but hearing the actual mechanics of it, they aren't therapists at all. They are acting like an air traffic controller.
Oh, I like that.
Think about it. The design department is a plane trying to land, production is a plane trying to take off, and purchasing is trying to route a third plane through the exact same airspace. And Sasaki is the control tower looking at the entire radar screen.
Right.
They are the only ones who can see that if these planes stay on their current trajectories, they are going to crash right over this 24 millimeter curve.
Right.
So they step in, rewrite the flight paths, provide the custom tools, and land everything safely.
That is a fantastic way to look at it. And when you act as the control tower, the power dynamic fundamentally shifts. A normal tape supplier is easily replaceable. You just find someone cheaper. But a supplier who acts as your early warning radar system, a company that prevents your factories from shutting down, they become an indispensable piece of your organizational infrastructure.
Which perfectly explains the next massive leap in their evolution. Because once you become that indispensable air traffic controller for major Japanese automakers domestically, they literally cannot function without you.
No, they can't.
And as those Japanese automakers expanded their manufacturing footprints globally, they essentially dragged Sasaki Coating right across the ocean with them.
Exactly. The problem pulled them outward. In 2013, Sasaki began a major expansion into North America, establishing ICS and later SCNA in 2024. But what they found when they arrived in places like Kentucky and Canada was a completely different landscape than Japan.
What was the core issue? Was it a technology gap?
No, not at all. It was an isolation problem. They found that these local North American Tier 1 factories were practically operate on an island. Back in Japan, there is a lot of unspoken communication, shared cultural context, and incredibly deep engineering support right down the street.
Right.
But in North America, these massive factories were trying to execute incredibly complex manufacturing processes, but they were cut off from the deep R&D support of their Japanese headquarters.
Yeah, the sources paint a picture of pure organizational chaos. It wasn't that the local engineers weren't capable, it was that the structural communication was totally broken. Blueprints were fragmented across different teams. One department would be working off an outdated CAD file, while someone else had an email with updated dimensions that they hadn't even shared.
And in that environment, no one wants to make a decision. There were entirely unclear commercial flows. If a specification needed to change, no one knew who was actually authorized to issue the purchase order.
No one wanted to take the blame if the change failed.
Exactly. During one major crisis, a vice president at a company called Vutec explicitly stated on the record, we'd be in trouble without Sasaki. because Sasaki realized that in North America, they couldn't just supply Tate, and they couldn't just supply engineering advice. They had to provide what they called project promotion infrastructure.
Project promotion infrastructure.
Hmm.
That is such a dry, clinical corporate term. What does that actually mean on the loud, chaotic floor of a factory in Kentucky?
It means they had to build the tracks while the train was moving. Sasaki, a Tier 2 supplier, essentially had to step in and map out the supply chain for their own bosses.
Uh-huh.
Look at the 311D and 806D projects. They had to sit everyone down and determine who actually holds the final quality guarantee for this part.
Right.
How are the raw materials physically getting shipped here? If we have to change the dimensions of this component, which specific budget is absorbing the cost of the air freight logistics, they had to design the basic conditions for success before a single part could be manufactured.
They're organizing the chaos, removing the friction. And again, when you are the entity that removes the friction, the customer just starts handing you all of their hardest problems.
Exactly.
But as I read through these reports, a glaring issue jumps out at me. Being a highly bespoke air traffic controller and having engineering geniuses who can look at a 3D model and instantly spot an R24 wrinkle, that is incredible.
Oh.
But it relies entirely on the individual brilliance of a few veteran employees.
Yes.
You have these master engineers who've been doing this for 30 years, who can fly to a factory, look at an assembly line, and just know what the problem is. How on earth do you scale that? What happens when those veterans retire?
You've just hit on the existential question facing almost every highly specialized manufacturing company in the world today.
Yeah.
The loss of veteran expertise. And Sasaki's answer to that threat is the next and arguably most ambitious phase of their evolution.
Tell me about it.
They introduced a strategic plan called Vision 2030 with a goal to scale up and become a 10 billion yen innovative solution provider, or what they call CX 2.0. To achieve that kind of scale without losing their magic, they are undergoing a massive digital transformation. They are taking 35 years of tacit artisan knowledge, that gut feeling a master engineer gets, and they are digitizing it.
They're building an operating system out of human intuition. And I absolutely love the name they chose for the system. They call it Freya, named after the Norse goddess associated with magic, strategy, and foresight.
It is a very intentional name because Freya is not just a passive database of past invoices or old blueprints. It is an active predictive system. It uses predictive analytics and smart inventory tracking, which they call SIMs, to flag risks before they happen.
Oh, wow. So how does that work in practice?
Imagine a customer sends over a brand new CAD file. Freya scans the geometry of that file, cross-references it with decades of historical data, past failures, and past successes, and automatically flags an alert saying, "Warning, based on our data from 8 years ago, this specific angle combined with this specific material is going to wrinkle."
That is wild. And it doesn't just stay in the digital realm, right? It bridges the gap directly to the physical factory floor. The sources detail how, in the coming years, like by 2025, Freya will connect directly to NC cutting machines for mass production, specifically for components like the RV4 doors.
Right.
And for those unfamiliar, NC stands for numerical control machines. These are automated, highly precise cutting machines driven by code. So you have the ruthless precision and logic of AI feeding directly into the physical blades, but the logic itself is entirely guided by the passion, sensitivity, and hard-won experience of the human engineers who built the system. They refer to this synthesis in the documents as creating a digital centaur.
A digital centaur. Half human, half machine, moving faster, smarter, and with more foresight than either could possibly achieve alone. And creating this centaur completely changes their business model, because suddenly they aren't just selling the time it takes to run a cutting machine, they're moving toward highly transparent pricing where they explicitly bill the client for development right alongside materials and processing.
That is a massive psychological shift. They are saying to the giant automaker, look at this invoice. You aren't just paying for the plastic and the adhesive. You are paying for the Freya analysis. You're paying for the TES methodology. And you are paying for the fact that we just eliminated $1 million of risk from your timeline.
Exactly. They're forcing the customer to acknowledge and pay for their intellectual value. And that shift in value is perfectly reflected in the evolution of their corporate motto.
Oh, right. The sunflower motto.
Yeah. For years, their guiding philosophy was called the spirits of sunflowers. The idea was that Sasaki Coating was like a sunflower, always looking up at the sun, and the sun represented the customer. They were always trying to absorb the light, follow the customer's lead, and meet their needs.
But with this new digital predictive era, they've upgraded that to Spirits of Sunflowers 2.0. They realized that just waiting for the customer to shine a light on a problem isn't enough anymore because, as we saw in North America, often the customer is fumbling around in the dark themselves. So the new philosophy is to actually be the sun.
Exactly, to be the heat source, to actively illuminate the entire supply chain and show the customer the safest path forward. If we pull back and look at the macro trends in global business, what we are witnessing here is a textbook, flawless execution of something called servitization.
Privatization.
Yeah, it's this massive movement where traditional manufacturers transition from simply selling physical goods to selling outcomes. Think of how Rolls-Royce stopped just selling jet engines and started selling power by the hour.
Right. Guaranteeing the airline that the engine would simply work and handling all the maintenance behind the scenes.
Precisely. Sasaki isn't just selling car parts anymore. They're selling the outcome of a flawless, friction-free manufacturing process. And the implication of that for their Vision 2030 is profound. It means that in the future, they might not just manufacture physical parts for their clients. They could package the Freya software platform and their entire TES consulting methodology and sell that as a service to the broader manufacturing industry.
So they're evolving from a town factory into a platform company.
They really are.
It is a staggering journey. From a small, chaotic start in the economic ruins of 1991, desperately hoping someone comes, they build it, to literally coding the operating system for how modern manufacturing should work.
It's an incredible evolution.
And for you, listening to this deep dive right now, I want you to take a second and reflect on your own career or your own business, regardless of what industry you are in. It is so easy to just put your head down, fulfill the basic requirements of your job description, and just, supply the tape.
Mm.
But are you acting like Sasaki Coating? Are you looking across the silos of your own organization?
That's the real takeaway here.
Are you actively hunting for those hidden R24 bottlenecks in your projects before they explode and cost everyone time, money, and stress?
Hmm.
Are you just waiting for the sun to shine on you? Or are you doing the incredibly hard, necessary work to become the heat source yourself?
Those are exactly the right questions to ask. But this evolution also raises one final, highly provocative question that I want to leave you with today.
Oh, what's that?
As systems like Freya get smarter and more ubiquitous, as we successfully capture decades of human intuition, trial and error, and that vital, messy, tacit knowledge into clean, efficient algorithms, what happens to the next generation of workers? If the machine already knows exactly where the material will wrinkle before you even look at the blueprint, how do young engineers ever develop that sixth sense that built the system in the first place?
Wow.
If we use technology to entirely remove the friction of making mistakes, do we also accidentally remove the crucible that creates human mastery? It is a paradox of perfect efficiency, and it is a challenge that every industry is going to have to face in the coming decade.
A paradox of perfect efficiency. That is a heavy, fascinating thought to chew on. You start by trying to fix a broken, chaotic landscape, clearing the muddy waters, and you end up having to figure out how to teach the next generation to swim in perfectly clear artificial pools. Thank you so much for joining us on this deep dive. Stay curious, keep asking the hard questions, and keep seeking out the brilliant mechanics hidden beneath the surface of the things we take for granted every day. We will catch you next time.